So today we're going to do 2-3, which is using deductive reasoning to verify conjectures. So we're going to review real quick some things we talked about last week. The first thing we're going to talk about is inductive reasoning. So remember, that's the process of reasoning through patterns and observations. So we use that to figure out the next number in a pattern, right? If it was 1, 3, 5, 7, the next number would be 1, 3, 5, 7, 9, right? Because those are just the odd numbers. So you're looking at patterns and observations. That would be inductive reasoning. An example would be there's a myth that you can balance an egg on its end only on the spring equinox. A person was able to balance an egg on July 8th, September 21st, and December 19th. Therefore, the myth is false because that was not on the spring equinox. Obviously, these are not on the spring equinox. How do we know that?
Because there's summer and
Right, the dates are in the summer, and the fall, and the winter, so the myth would be false. Okay, deductive reasoning is the process of using logic to draw conclusions, and those are going to be from facts, definitions, and properties. So before, we were using patterns and observations. Now there has to be facts, or a definition, or a property. So you can think of inductive reasoning as something that's intuitive, something that you observed, some kind of pattern that's happening, whereas deductive reasoning is going to be based on facts. And so an example of that would be, there's a myth that the Great Wall of China is the only man-made object visible from the moon. The Great Wall is barely visible in photographs taken from 180 miles above the Earth, and the moon is about 237,000 miles from the Earth. Therefore, the myth would be false. So this would be based on facts. So the fact would be the moon is about 237,000 miles, and the Great Wall is barely visible taken from 180 miles. So if it's barely visible from 180 miles, is it going to be visible from 237,000 miles?
No.
No. Okay, so that's a fact that we're using to determine the truth value. Our next example is we're going to determine if it's true from inductive or deductive reasoning. Okay, so I'm going to give you a minute to read through that. Okay, and then after you've read through it once, when you're deciding if it's inductive or deductive, I want you to try to underline or highlight a piece of the information that's going to support whether you think it's inductive or deductive. And then I'm going to give you about 20 seconds. I want you to consult with your elbow partner and see if they chose inductive or deductive, and then what the evidence
Shut up, I show you. Yoskin, run up, deductive है.
I know, I'm saying it's deductive because.
Shut up. I'm telling you, it's deductive है.
You're right, Jay.
It's like some little kidless. Ring it. Oh, that was the worst highlight job I've ever seen. What are you doing with yourself? I already made a line. Why did you make another?
Because I was like, man, it's so wavy.
Shift up.
All right, let's see what we came up with here. Okay, so a lot of us came up with deductive reasoning. Okay, that is excellent. If it's deductive reasoning, what I highlighted, and maybe you guys did this too, is that eelskin products are not made from electric eels. So that is, you have to ask yourself, is that a fact or an observation, right? Well, that's a fact. You're not making eelskin products from electric eels. So therefore, we're using deductive reasoning for why the myth cannot be true. All right, and then we're going to move on to the law of detachment. Okay, the law of detachment. So the law of detachment tells us if P then Q is a true statement, okay, so if the conditional, if P then Q is true, and P is true, then Q has to be true. Okay, so if the statement P to Q is a true statement and P is true, then Q has to be true. So this can be kind of tricky. We're going to go over this together. So determine if each conjecture is valid by the law of detachment. So the first thing, it says given. In the World Series, if a team wins 4 games, then the team wins the series. The Red Sox won 4 games in the 2004 World Series. The conjecture is the Red Sox won the 2004 World Series. So the first thing I do is I take the statement and I label my P and my Q. Okay, so the P is my hypothesis, the Q is my conclusion. So for this given statement, it says if a team wins 4 games. So a team wins 4 games. That's my P value. The team wins the series. That's my Q value. Okay, so the Red Sox won 4 games. If they won 4 games, does that satisfy the P or the Q? It satisfies the P value, right? Okay, so then can we make a conjecture based on that they won the 2004 World Series?
Yes.
Yes. Okay, so this is telling you that P is true. Well, the law of detachment tells us if P is true, that Q has to be true. Okay, so if P to Q is true and P is true, we know that that is a valid conjecture. Okay, so then for this, you would say that it's valid. It says determine if each conjecture is valid, so it's either valid or you could say not valid or invalid if it was not true. Okay, so for the next one, for the next given, I want you to try to label what your P and your Q statements are. Okay, so Baron, what's our P statement for this?
If you were tardy 3 times.
Okay, so the you are tardy 3 times. That's going to be your P value. Your Q value should be must go to detention. Okay, then it says Shay is in detention. So the fact that Shay is in detention, does that satisfy the P is true or the Q is true?
The Q.
Okay, so can you guys see that the detention part is the Q part of the statement? Okay, yeah, so that is our Q, and it says your conjecture is that Shay was tardy at least 3 times. No, that's invalid. We don't know if that was true. We can only say if P is Q, then Q is true. We can't go backwards. So we can't say if Q is true, then P is true. Okay, so Shay could be in detention for a completely different reason. We just know that if she had 3 tardies, then for sure she's in detention. But if she's in detention, that doesn't necessarily mean she had the 3 tardies. Okay, so you can either write invalid or not valid. Okay, do you guys have questions for me? I know this will just come a little bit easier as you practice. Right now it's just a lot of theory. Okay, let's flip it over. Okay, the next thing we're going to talk about is the law of syllogism. And this is also called the transitive property. This law tells us if P then Q and Q to R are true statements, then P to R is a true statement. Okay, so if you have 2 true statements, the first one would be P to Q, the second one is Q to R, then P to R is a true statement. Okay, and we're going to talk about that because I know the R is a little bit different than what you're used to. So we have to determine if the following conjectures are valid. So I'm going to, again, the first statement, I'm going to label the P and the Q. So our first statement, if a number is divisible by 2, then it is even. Okay, if a number is divisible by 2, then it is even. So our P value is going to be a number is divisible by 2. Even is going to be a Q. Now, do you notice in the next statement that, again, they mention a number being even? See how we already talked about that here with the Q? So that's going to stay our Q statement. And then it says if a number is even, then it is an integer. Okay, so basically it's 2 different statements that are used together, and if they line up in a certain order, then we can assume P to R is true. So if a number is divisible by 2, then it's even. That's true, right? If it's divisible by 2, it'll be an even number. If it's an even number, then it's an integer. Okay, so this is going to lead us to believe that if a number is divisible by 2, it is an integer. And let's talk about our conjecture. Okay, so the conjecture is if a number is an integer, then it is divisible by 2. So the first thing we're going to do is we're going to write down our P and our Q and our R. Okay, so our P value is a number is divisible by 2. I want you to write down your Q and your R. So we've already identified them, we just have to write them down now. Right, and I do want you to write this down in the space here. Okay, so for Q it is even, or if you said a number is even, that's perfectly fine. How do we do with that one? Is there to find that? Okay, and then for R it is an integer. Okay, so your conjecture is if a number is an integer, then it is divisible by 2. So if a number is an integer, that's our R statement. Okay, then it is divisible by 2, that is our P statement. We can only say what is true. So what's the law? The law is if P to Q is true and Q to R is true, then what is true?
The whole stage.
P to R. Okay, so is this going to be P to R? No, what's that statement? R to P. So if it's R to P, then it's not valid. Okay, so the order is going to matter. We are going to write what a valid conjecture would be. So I just added in this here. What would a valid conjecture be? So let's think about that. We just talked about a valid conjecture would have to start at P and go to R. Do any of you think you can tell me what a valid conjecture would be? From P to R? Yeah, Jay.
If a number is divisible by 2, then it is an integer.
Okay, good. Brandon and Maddie, do you guys agree with that?
Yeah.
Okay, so if a number is divisible by 2, it is an integer. Okay, so your p-value, if a number is divisible by 2, your r value, then it is an integer. Okay, and then I'm going to give you some time to try the next example. So again, you're writing down your P, your Q, and your R. can you tell me what you wrote as your p-value?
A figure is a
Excellent. So for your p-value, a figure is a kite. Avery, what did you write for your q-value? Okay, good. It is a quadrilateral. And Jana, what did you write for the last one?
It's a polygon.
It is a polygon. Okay, good. Do you have questions from you about picking out your P, Q, and R? Those are okay? Right? You can see where I also highlighted them above. So if a figure is a kite, then it is a quadrilateral. If a figure is a quadrilateral, then it is a polygon. The conjecture is if a P is a kite, then it is a polygon. So the first part, the hypothesis was P, the conclusion is R. So if it's P to R, is that going to be valid or invalid? Valid. Okay, so this statement here is showing you that this goes from P to R. So if it's going from P to R, that's going to be valid. Okay, so you should have valid written somewhere in your box. Then the last thing we're going to do is draw a conclusion from the given information. Okay, draw a conclusion from the given information. So it says you are given that if 2y equals 4, then z equals -1. Okay, so this is going to be my p-value. If 2y equals 4, then z equals -1 will be my q. Okay, and so I'm going to write these here as well. So your p is 2y equals 4. Your q is z equals -1. Okay, now this next one here, if x plus 3 equals 12, is that mentioned in any of the other places?
No.
No. So then what do we have to call this?
R.
Yeah, we're going to call it r. Okay, so then we have r, which is x plus 3 equals 12. And then it says, then 2y equals 4. Is that something that we've already done before?
Yep.
Yeah. And that was your p-value. Okay, and then it's saying, the last thing it says is x plus 3 equals 12, and this is going to be our given statement. So if this is our given statement, this is what value? What's your given statement? X plus 3 equals 12 is your R, right? Okay, so this one's a little bit different. So see how whenever I got something new, I labeled it as my R?
Yes.
Yeah, okay, and then this already happened, so I gave that the same label. This is your given. So you are given that x plus 3 equals 12. So let's write out what we have. The first thing that you're given is that P goes to Q. The second thing that you are given is that R goes to P. For this one, you are not trying to figure out if it's valid or not. There's no conjecture, right? You have to figure out what the conjecture is. So if you're given that x plus 3 equals 12 is true, you have to find out what's going to follow from that. Okay, so we know if P then Q, if R then P. And you are given R. So let's go ahead and start with R. If we start with R, then we know P is true. If P is true, then Q is true. So what would my new statement be? Yeah. Okay, good. So then that means R to Q would be true. So then what can I conclude? If x plus 3 equals 12, What's my conclusion? No. So if R is true, right, then Q is true, right? So this is going to be our conclusion, right? What's our Q value? Yep. So your conclusion is that Z is equal to -1. Okay, so because we were given R, and we know if R then Q, our conclusion is going to be our Q value. Okay, and then your homework is up above there. So that's going to take some practice as well. Oh, because that's what you're given. So if it's given, then you know it. If it's given, yeah. So with your last statement, whenever you're given something, then you know that that's true. So if you're given P then Q, that's true. If you're given R then P, then that has to be true. And then you're also given the x plus 3 equals 12. You know that's true. You have to find the conclusion to that. That it is 2 through 8 evens, 9 through 12, 15 through 18, 23 and 24, 29 through 31, and 36.